Welcome back. Now we're going to get started writing our first program. This is going to be a simple program, but it shows the basic anatomy of a C++ program, and it also shows you how you can display text in a console window. Usually a programmer's first task when they're learning a new programming language is something called a Hello World program, which is just a simple text program that displays the words Hello World on the computer screen. We're going to twist that a bit, and instead we're going to write a game over program that will just display game over on the console and then return a new line. So I've got my text editor here, and I'm going to go ahead and start typing in my code. And I will explain what all of this means after we see what it does. Okay, with that done, I'll go ahead and save my file. And I'm going to name this game_over.cpp. Remember that CPP extension means that it's a C++ source code file. And that's saved. And if I go over into my terminal window, I need to get into the correct directory. Okay, and I see my source code file there. So now I want to compile that program. And since I'm on my Mac and I don't have an IDE, I'm using the G++ compiler. And I just type G++ game_over.cpp. Now, if you are on Windows, this probably won't work for you. But the directions in the back of your text will take care of all that for you. And I have an error in my code, and I see exactly what that is. So I will fix that, and I've saved my file, and I will recompile. Okay, now if I list, I now have two files in that directory, game_over.cpp and a.out. And you can see that a.out is an executable. We see that here with the X. Basically, that means I can run it. But I do have to specify where it's located. And you can see that it just displays game over and then hits a new line. On the Windows side, you would double click on that, and what you'll see is that it goes away real quick. But we'll talk more about that later. Now let's take a look at what we've done. The first two lines of our program are comments. These are completely ignored by the compiler. They're just meant for us humans. Comments can help other programmers understand what you're doing, or they can remind you how you pulled something off when it was really complicated and not obvious. You create a comment by using 2 forward slashes and then whatever you want your comment to be. Anything after those 2 forward slashes, the compiler will completely ignore. It won't pay any attention to them at all. In fact, I could even include comments at the end of a line of code, like so. Okay. That's one way you can do comments. I generally prefer to have my comments outside of my code, but if you just need a quick explanation of what a line of code does, then you could put your comment there. The other way you can include a comment is by using what's called C-style comments. And C-style comments use the slash and the asterisk. Okay, so it's the / and then an asterisk. And if you use C-style comments, everything is a comment until you close that C-style comment by using the asterisk /. So you can see that the asterisk and the / just kind of wrap around your comment. So this would also be ignored by the compiler. Okay, our next line is just a blank line. And this will also be ignored by the compiler. As a matter of fact, the compiler is going to ignore just about any white space. Spaces, tabs, and new lines. The white space is just for us, for people. It helps us organize our code, makes it easier to read, easier to understand. For example, if you take a look here inside our curly braces, I've used the tab key to set these 2 lines of code off from my curly braces. Makes it easier for me to see where my curly braces begin and end, which is really important as you get more into programming and realize that curly braces are used within functions, and if you don't close them in the right place, then you get unexpected results. Okay, next line of our program, include IOStream. This is called a preprocessor directive. You can tell that it's a preprocessor directive because it begins with the hash sign, okay, that number sign. A preprocessor directive runs before the compiler does. That's why they're called preprocessor. And they substitute text based on what directives you use. In our case, we've used the include directive, which tells the preprocessor, take the text of the file that I'm about to tell you and substitute it here. The file name that we've indicated is IOStream. Now, IOStream is part of the standard library. It contains the code that helps me display output on the screen. I've surrounded the file name with a less than sign and a greater than sign. What this does is it tells the compiler, find IOStream wherever you keep all of the files that are included with the compiler. So this line of code, what it does when we start compiling, is it takes the IOStream file, which is found wherever the rest of my compiler library files are located, and it substitutes the entire text of that file for this one line. This is basically a good way so that you don't have to retype functions and objects that you use frequently. You can just include them and you don't have to retype them. Okay, now you might hear these types of files referred to as header files, especially if you ever get involved in any form of Unix programming. You will hear a lot about header files, and in fact, quite often the files will end with a .h to indicate that they're header files. Next line is also a blank line, so it's ignored. And now this is the header of a function called main. A function is a group of programming code that does some work and then returns some sort of value. int means that we've declared this function to be an integer. What that means is that the value returned by the main function will be an integer. And then we have the parentheses at the end of our function name. You'll see that with all function headers. They will always have a parentheses at the end of the name. Now, we've called this main because that is one thing that's required for all C++ programs, a function called main. This is the starting point of the program. If you don't have any other functions, you've got to have a function called main, or your program just won't do anything. Next, we have an opening curly brace. This shows the beginning of the function, and you'll see the matching curly brace here at the end of the function. Inside of these curly braces is where the action really happens. Our first line of this function displays the words game over, exclamation mark, and then a new line. We do this using the cout object right here, and cout is actually defined in IOStream. It's an object that we don't have to define because the developers of the C++ programming language have already done that for us. Cout sends data to the standard output stream, which is usually the console window on the computer screen. Okay, next we have an output operator, these two less than signs. Think of this like a funnel. Okay, this output operator sends our string to cout. So if we've got a funnel here, the open end of our funnel is where you would pour stuff in, and then it would go through the funnel, out the spout or the pointy end, into whatever container you were sending it to. In this case, that container is cout. So our string gets funneled to the standard output. After that, we have endl, using that same output operator. So we're also funneling endl after game over into our standard output. endl is also defined in IOStream, and it stands for end line. It's the equivalent of hitting the enter key or the return key on your keyboard. Okay, so now let's take a look at how we call cout and endl. We have used the std and two colons right before our object names cout and endl. This basically stands for standard, the standard library. It tells the compiler to take these objects from the standard library. STD is a namespace. It's kind of like the area code of a phone number. If you wanted to call my office at work, you couldn't just dial 941-4675. The phone company wouldn't know what city to send your call to. So you have to give the area code, 330. If you've got several places where cout and endl might live, and let's just assume that you do, then you have to give the area code, or in this case, STD. Okay. Now, this is, like I said, a namespace. Anytime you're specifying a namespace, you use what's called the scope resolution operator between the namespace and the object. In C++, the scope resolution operator is a pair of colons without any spaces. If you want a visual look at how all of these elements fit together, Dawson provides a pretty good job, pretty good figure displaying that on page 9 in your textbook, figure 1.3. Okay, now you might notice that the end of our lines here end in semicolons. This indicates the end of a statement, and the statement is the basic unit controlling the way our program flows. All of your statements have to end with a semicolon, or the compiler will throw an error message and your program just won't compile. We don't have a semicolon here. The reason for that is because this include is not a statement, it's a directive. Our preprocessor directives don't need semicolons. Our headers don't need semicolons. Okay. Our last statement in this function, return 0. This returns the integer 0 to the operating system. Remember when I said that because we were declaring our function as an int, as an integer, it would return an integer? Well, that's what this line does right here. It returns 0 to the operating system. And this is a way to tell the computer that the program ended without any problems. An error of 0 means that there was no error. If we were doing more advanced programming and we wanted to include error codes, we might return those error codes here. Okay, now if you run your program by double-clicking that executable on Windows, you might just see a flash as your command console window opens, the program quickly runs, and then it closes again. This is because C++ works so fast that our short program is done in just a split second. If you want to see what the program does and you're running Windows, what you need to do is create a batch file that will run your program and then pause. This will allow you to see what the program has done and then close that window when you're ready to close it. So you're going to create a batch file using any text editor with just these lines. gameover.exe, which is the name of the program that you've created, and then pause. Once you've done that in your text editor, you're going to save that file as, and we'll just call it gameover.bat. Okay, now I don't have Windows here, so I can't show this in action, but you would then go into Explorer, go to your directory, double-click on the gameover.bat batch file, and that would run your program in the command console window, and then it would pause so that you could see what had happened, and then you could go on and close it once you saw what happened. Okay, so now what we're going to do is we're going to create version 2 of our Game Over program. We're going to revise our program a bit and use something called a using directive to change how we access cout and endl. Okay, in version 2.0, we're going to add a directive, a using directive. So we type using namespace ::std semicolon. This gives me direct access to all of the elements of the std namespace. In other words, all of the elements that are in that std namespace will be local numbers in our program. So we can remove the std : prefix from cout and endl. And we'll go ahead and save this. And we'll save this as gameover2.cpp. I'll go back into my terminal window, and I'm going to compile gameover2.cpp. And I run my a.out object. Looks exactly the same, doesn't look any different, but we've saved ourselves a bit of typing. Now there's another way you can do this, and in version 3.0, instead of using the using directive, we're going to employ something called a using declaration. So instead of using namespace standard, we're going to add using : cout and using std : endl. And I've taken out the using namespace standard directive. When we do this, instead of writing the using directive, we clearly spell out which elements from that std namespace we want to use, and then we avoid making local a ton of other things that we really have no intention of using. So now I'll go ahead and save this as gameover3.cpp. Back in my console window, I will compile gameover3.cpp and run that object. Still looks the same. All we've done is we've saved ourselves quite a bit of typing. Well, just a little bit here, but in the long run, this would save you a lot of typing. Now, a programming language purist would say that you should always specify the namespace of that object. I follow the theory of don't repeat yourself. So if you know that you're going to be using the same object multiple times, it's best to declare it at the beginning of your program so that you don't have to keep typing the std : cout. All you have to type is cout and endl. Okay, that's it for this week. Next week we'll look at the rest of Chapter 1. We'll learn about arithmetic operations, variables, and constants. So have a great week and enjoy your weekend.